Good morning, dear students. My name is Dr. Rajesh Sarkar. I am the Associate Professor at HOD of PC Department, Hyderabad Institute of Technology and Management. I have completed my BTech in 2005 in Islamabad, University Institute of Technology. My Master of Engineering from Usmania University with specialization of Micro and Data Engineering. I have completed my PhD in 2023 from JNTU Kakinada. I have qualified great time in it. So I have that 16 years of teaching experience, 2 years of research experience. I have published in more than 10 reputed journals. So with my specialization, I am going to be handling the electromagnetics in this current semester. So as we are aware that we completed electromagnetics 4 Maxwell's equations in last 4 units, and as well as wave propagation, wave characteristics in the 4th unit. As we know that uniform plane wave. What is uniform plane wave? Before going to start, we need to know that what is a wave. Wave carries the information, as we know that, and it is a recurring function, or simply a recurring function of time. Now, what is actually the main definition of the wave? Wave is a physical quantity. It is available at this location at this time, and it is relocated at another location at later time. The time delay is being proportional to the space separation between the elements. So, what is wave? Wave is a physical quantity available at one location. It reproduces at another location at a later time. The time delay is being proportional to the space separation between the elements. Now, as we know that the uniform plane wave is traveling in what mediums? Generally, it can be traveled in unguided medium and guided medium. What is this actually unguided medium? Unguided medium, it does not have any boundary. Guided medium consists, it is a boundary. In that, what is the best examples of unguided waves? In unguided waves, we need to be transmitting the information. Let's the starting location we can call it is a source, and it is a load, and it is the input, it is a output, and we can call it is the source and the destination, and the starting point, ending point. In between, what way this information we are sending from one place to another place, either through wireless medium or through wired medium. That is what the basic differentiation about that. But unguided medium is simply a wireless medium. Guided medium is simply a wired medium. So what it consists? Generally in unguided medium we need to transfer the information from one place to another place. So one place to another place, the example itself is radio waves, TV waves. Whoever they want the information, they will be received. But whereas in the guided medium, we will transmit the signal from one place to another place at a particular person. Means that best example of our switching on the lights and fans from the transmission line source we have. In between we have a switch. Then if we switch on the signal, which switch you have to be on? If you are on the light switch, light will be glow. If you are on the TV switch, TV will be glow. Like that. But whereas you come to the example of unguided signals, if I want to be received that FM signal, you will be received FM radio. If I want to receive the radio signals, then radio AM signal you are going to be received. If I want to receive the TV signal, you have to be placed parabolic antenna, then the signal is coming from the parabolic antenna, we will be received. Like that mobile, if I switch on my mobile, insert the SIM card, I want to receive the mobile signals, we will be received, GPS signals. These all other, whoever the requirement, signals are available in free space, that signals we are receiving the whoever the requirement, according to that we are placing an antennas, we are receiving. But in the guided medias, then point to point communication is takes place. Point to point communication is takes place. What are the guided mediums examples? We have transmission lines. That the guided medium we can call transmission lines. In that we have two-wire transmission, coaxial cable, then later we have optical fiber, and we have waveguides, and we have microstrip lines. What actually the two wires? Two wires we will be take. We are guiding the wave from source to destination from one place to another place. Similarly, coaxial cable. We have center conductor and outer conductor. We will be sending the signal from source to destination. Similarly, optical fiber. Load and cladding we have. We will be transmit the signal from the laser to the total internal reflection from the source to destination. Finally, we have a waveguide. In that waveguide, the metallic device we are using as the boundary. Through that signal, the wave can be propagated from source to destination. Finally, microstrip antenna. It is having the ground plane. In between, there is a dielectric. Again, we will place one strip here. So, from one place to another place. Then, if it is suppose an antenna, this is a transmission line. To giving that feed from source to the antenna, we will use microstrip lines. These are the transmission lines literally we will use. But what actually, while we are propagating the signal, this is the overall length of the signal. Let's you can consider the transmission line source. If I am going to be apply V and current carrying I, then I want to be transmit to the ZL load impedance. For that, if I have the V1 and I1 current is going to be takes place, usually no perfect conductor is available based on the media parameters like copper, aluminium, whatever it may be, gold. Based on the material, the conductivity of the properties are going to be takes place. Some losses could be take place. This is simple. We will have four important constants we will get in the transmission line that we can call as primary constant, which are very, very important. What are the primary constant? R, L, G, C. Resistance, inductance, conductance and capacitance. How we will get this resistance? As we know that all conductors are not perfect dielectric, not perfect conductors, then we will have some losses while transmitting the power from source to the destination. That losses we are going to be denoted with resistance. If it is per unit length, or we are going to be indicated with ohms per meter. Similarly, when I apply the voltage, current is transmitting through these conductors. Whenever the current carrying conductor is there, obviously we know that there is a magnetic field is exist around the conductor. That magnetic field we denoted with in inductance. How we will store the magnetic field? In the form of inductance. That we can call as inductance. L we can indicate Hertz per meter. Similarly, when I am applying a potential, then there is a field exists between these two wires. That field we know that electric field. As we know that two parallel plate capacitor, if I apply the voltage between the two parallel plates capacitor, separation between the elements is D, then the electric field equals to V by D. Then that electric field we denoted with capacitance. And we know that this capacitance is interlinked with the conductance. That conductance we are denoting with your G. So how we will indicate farads per meter, then moles per meter. So these all are in the distributive nature. Small distance we will take on this transmission line. That distance we can call as delta x. So from that we will be write an equivalent circuit. Resistance R into delta x and inductance L into delta x and capacitance C into delta x. Similarly, conductance G into delta x. These are the four primary constant, and this is the actual equivalent circuit of a transmission line. And from this, what is the conclusion? These are the nature of distributive. That is the reason we can call these elements are distributive in the nature. So these are the very important parameters, how it is going to be behaves and how will the analysis we will take. That is the only reason, instead of taking that EM theory to analyze these all parameters, for simplicity we go with Circuit theory. Circuit theory. If you know the KVL and KCL, it is good enough to be identified. In the next class, we will be see how to be identify that transmission line analysis using that the circuit theory of voltage and current at the source end and at load end. What is the characteristic impedance? What are the parameters of the reflection and refraction, VSWR meter, reflection coefficient. Further classes we will study in detail about these parameters. Thank you everyone.